Okay, so fundamental theorem, the evaluation part, which is considered part one. There's two parts to it. We'll do part two later, but part one is you do U substitution, or you do whatever you do antiderivative. First step is antiderivative. If you need to use U substitution, you use it. If you don't use it. And then the second step was you plug it back in and subtract. Okay, that was what we did yesterday, right? Find the antiderivative, plug in the top bound, plug in the bottom bound, subtract, right? So let's go to, we stopped at number 5. Okay, so what's the first step for, if I'm doing this problem, don't worry about the bounds. Again, bounds, meaningless right now. Bounds, I could care less that there's a 5 and there's a 6 there. Could care less about it, right? They don't exist to me right now. Right now, my focus is finding the antiderivative. So if I was doing this problem, what would I do first to find the antiderivative? Rewrite it. Good, rewrite it. No fractions. When we're doing antiderivatives, we don't like those. Okay? So we're going to rewrite it. So I have 2 times 7 minus x to the negative 1 power dx. So I have 2 questions. First question, can I distribute the 2 to the 7 and the negative x? No. Yeah, no, I can't because of this power here. The second question, can I move the 2 to the front? Yes, and that's what I'm going to do. I'm not going to worry about the 2. The 2 is going to move to the front, and then I'll deal with it later. Okay, now I'm here. U substitution. I only got one thing to choose, this guy right here. So U is going to be 7 minus x. Du is going to be negative 1 dx. Divide by negative 1. You're going to get negative 1 du equals dx. Okay. That's the u part. Now I'm going to do the substitution part. I have 2, 6, 5, u, negative 1 power dx. Okay, so what's the antiderivative for u to the negative 1? How do I do antiderivative for this guy here? I add a power, so I get 0, and then divide by that new power, 0. We've run into this, I think, twice before, at least twice. I can't use the power rule. I can't add a power and divide by a power because I can't divide by 0. So when I get this, what do? Natural log, right? This is natural log. So the derivative, write this down. So the antiderivative for anything to the negative 1 power is going to be natural log of u. When you can't use the power rule, that's when natural log happens. Okay? So we write 2 times the natural log of u. I don't need a plus c since I have bounds, 6 to 5. You just draw a line and say 6 to 5. Uh-huh. Did I do something? Oh, yeah. Sorry, yeah. Let me go back a step. Thank you. So I forgot to plug in, should be du, times negative 1 du, yeah. So the negative 1 can move to the front with a 2. So I got negative 2 times the natural log of u, and I have to evaluate that now from 6 to 5. Because the negative 1 moved in front. Then multiply. Okay. So now I got to put u back in. Negative 2 times the natural log of 7 minus x, and I'm going to evaluate that from 6 to 5. Evaluate just means plug in. Plug in 6, plug in 5, you're done. Negative 2. Actually, give me some more space. So negative 2 times the natural log of 7 minus 6 minus negative 2 times the natural log of 7 minus 5. Finish it. What do you get? Okay, so negative 2 times the natural log of 1 minus negative 2 times the natural log of 2. Well, the natural log of 1 we know. What is the natural log of 1? 0. So this guy is just going to be 0 minus. The natural log of 2 is some number that I don't know. So I'm just going to leave it the natural log of 2. So negative 2 times the natural log of 2. Minus a negative, you're going to get 2 times the natural log of 2. Okay. All right. So that was a natural log problem. Now I'm going to give you an E problem. An E. Again, don't worry about 0 and 5. We'll deal with that later. All we're worried about right now is finding the antiderivative. That's our first step. Oops, x. So earlier this week, I think it was. Yeah, when we first started doing u substitution. Does anyone remember what I said when I said when you're doing antiderivatives for anything with e? If the power is something other than just regular x, that's where to start with your u. More than likely, that's going to be where to start. In this case, this guy has e to the negative, it's 1/5 x, negative 0.0, negative 0.2x, right? Negative 1/5. So if e has a power other than x, that's where I would start with u. Make that u, make the power u. More than likely, that's going to be the x. It's not going to be e to the whatever, it's going to be just the power. So the derivative of that is negative 0.02 dx divide by negative 0.0 or 0.2. So it's really 1 divided by negative 1/5. So when we're dividing fractions, aren't we really multiplying by the reciprocal? So instead of negative 1/5, it's going to be the reciprocal of that, which is negative 5. Okay. All right, so let me plug everything back in now. Okay, so 5 to 0, 8e, that's going to be u, minus 8, oops, times 5, or sorry, negative 5, du. Because I plug in dx, and that was negative 5 du. Do I have any x's left? Are there any x? Just u, right? I just have one u. U's are okay. I got a u here and a u here. I don't want x's. After I do u substitution, I don't want any more x's. So yeah, it works. So the negative 5, what am I going to do with the negative 5? I can put it to the front, right? Can I distribute it? I could distribute it. Either one's okay. Doesn't matter to me which one you do. You can move it to the front, or you could distribute it here and distribute it here. Doesn't matter to me. You're going to get the same answer. Since we've never distributed, I'll distribute this one. But you could move it to the front and deal with it later. It's okay. It's okay. Okay. So to do the antiderivative here, I'm going to split it up into 2. You don't have to do this, but I think it would be easier to see it this way. Okay, so what's the derivative of negative 40 e to the u? Now the negative 40, that's a coefficient. So you can move that to the front. So in other words, it's just what is the derivative of e to the u times negative 40? So what is the derivative for e to the u? E to the u has the easiest derivative, I think, out of everything you've ever looked at. E to the u has the easiest derivative. Why? No, it's even easier than that. What is the derivative of e to x or e to the u or e to the y or e to the anything? No, easier than that. Itself. Itself. Just itself. So literally the derivative here is going to be negative 40 times the derivative, which is e to the u. And what's the derivative, or what's the antiderivative, I should say, of 40? So yeah, so 40, it would be 40x divided by a power. Since we're using u's, we'll just use u. And I'm going to evaluate that from 5 to 0. So the first thing I got to do is plug in my u's back, and then plug in 5, plug in 0. U was negative 0.2x. So everywhere there was a U, I plugged in negative 0.2x. So now everywhere there's an x, I'm going to plug in a 5, and then I'm going to plug in a 0, and then I'm going to subtract those two. And then I'll be done. So the first thing is plug in 5. Everywhere there's an x. Then you're going to do the same thing, except I'm just going to plug in a 0. Okay. So I get negative 40 e, negative 0.2 times 5. So in other words, negative 1/5 times 5 is just negative 1. Same thing there. So it's going to be negative 40 here. Because negative 0.2 times 5 is negative 1 times 40 is negative 40. Zero. So negative 40 times e to the 0 power plus 0. Okay. I'm going to clean this up as much as I can. So this guy I can rewrite as negative 40 over e to the first power, or just e, right? Because it's got a negative 1, minus 40. When I distribute the negative, it's going to be plus. What is 40 times e to the 0 power? Anything times e, anything to the 0 power is always going to be what? 1. So it's really negative 40 times 1. Well, negative times a negative makes a positive 40. The 40s then will cancel out, and you're left with negative 40 over e. Okay. So anytime you see e to anything, if it's e to the x, make e to the x u. If it's e to some other power, make the power u. That's the kind of the cheat sheet way to do it. Okay. 2 more we're done. Okay, so absolute value. How do I find the antiderivative of an absolute value? Draw a picture. Yeah, the answer is kind of a trick question. How do I find the antiderivative or derivative of a absolute value? The answer is you don't do it. You draw a picture. You guys saw this one. You guys saw one similar on your quiz a couple weeks ago, right? Draw a picture. Don't mess with any type of power rule or U substitution. Anytime you see those bars, draw a picture. Okay. So this one, we're just going to do exactly like we did on the quiz. We're going to go from 0 to 5. I'm going to see what type of shape it is. So I'm going to plug in 0. If I plug in 0 for x, I get -2 times 0. 4 minus 0 is 4. The absolute value of 4 is 4. Then I'm going to plug in 1. If I plug in 1, I get -2 times 1 is -2. 4 minus 2 is 2. Absolute value is +2. Plug in 2. If I plug in 2, I'm going to get 0. When I say plug in, I mean plug in right there. 3. When I plug in 3, I'm going to get -2, but then the absolute value is +2, right? So yeah, it's going to be +2. When I plug in 4, I'm going to get 0. Or sorry, -4. Sorry, I'm going to get -4, but the absolute value of -4 is 4. When I plug in 5, I'm going to get -6. The absolute value of -6 is +6. Draw my sketch. Find the area under the curve. Everything's above the x-axis, which is true because it's absolute value. You have two triangles. Find the area of both triangles. So you got a 2 by 4, so 2 times 4 divided by 2. That's going to be 4. Then you have 1, 2, 3 by 6. That's 18 divided by 2 is 9. So area will be 13. Done. Just like you did on the quiz. No difference. Okay. All right, last one. Another trig one. So I have two options for you. How do you know when you're going to use U substitution? Well, you kind of look at it the same way you would look at a derivative. If I was doing derivative of this guy, if I was finding the derivative of this equation here, I would need to use the chain rule. If that's true, you're probably going to need to use to find the antiderivative, you're probably going to need to use U substitution. Okay? They don't work the same, but they go together. Okay? So I have two options. I have two options for U substitution. I can do the whole thing, sine of 2x, or I can just do 2x. Which option am I going to choose? That's the nice thing about U substitution. If you do it wrong the first time, you just do it again. Right? It's not like there's only one way to do U substitution. U substitution, you kind of correct yourself. If you pick the wrong one, you just do the problem again, pick another U, pick the U you didn't choose, and then you work it out. Okay? So what's the derivative? So again, this is how to tell. If I were to choose the whole thing, sine of 2x, what's the derivative for sine of 2x? Because that's the first step I'm going to need to do, right? Cosine of 2x times 2, right? Now, do I have a cosine of 2x in here? Is there anywhere in here where I have a cosine of 2x? No. So let me choose 2x. What's the derivative of 2x? 2. No x, no nothing, right? So if I were to divide, I would have 1/2, right? That can just go in the front. There you go. That's how you find your U. That's how you decide whether it's U substitution, which one it is going to be. Is the derivative of what I'm choosing in there? If it's yes, then go for it. If it's no, choose something else. 2x 2 du. Okay. Here's my u. Plug it in. What do we got? Sine of u times, and then I'm going to put the 1/2 in the front. I'm just going to do that. I'm going to skip that step. I'm going to put the 1/2 in the front. Okay. I'm not worried about the bounds right now. I'm not worried about the bounds. Bounds are meaningless to me right now. All I'm looking at is this. What is the antiderivative of this? What's the antiderivative of sine? Cosine. Okay. So then you're going to rewrite it. I don't need a plus c since I have bounds. Move u back in. Okay. Last step, plug in pi over 4, plug in 0, see what you get. Okay, so 1/2 times cosine of pi over 2, because 2 pi over 4 reduces there, minus 1/2 times cosine of 0. Well, cosine of pi over 2, I believe, is 0. Times 1/2 is 0. But cosine of 0 is 1, because cosine starts at 1. So it would be negative 1/2 times 1, which is negative 1/2. Okay. All right, since we got about 12-ish minutes, I'm going to give you one more problem. One more problem to try in the notes. The more problems in the notes are better, so you can always have something to go back to. So let me see here. Try a good one. Let's try this one. So example number 9. Let's see. So we got from 5 to 1, x over root. Find area under the curve. I'll give you the answer. The answer is 16 over 3. See if you can make it work. It was a problem like I showed you guys earlier because of the u you had equal powers. So if you have equal powers, you have to kind of do something different. So I found u, and then I solved for x. I didn't finish it, but that's how we did the last problem, where I had that missing x. I had that x left over, that x left over here, x left over here, that I couldn't cancel out. So what I did was I found what x was equal to using u. If u is equal to 2x minus 1, I added 1 and divided by 2, and I found this. So that's what I plugged in over here. So I got to distribute. I haven't done antiderivative yet. But you would get, let's see, 1/2 u to the 1/2 plus 1/2 u to the negative 1/2. Okay? Use the power rule. Plug u back in. Go from there. I'll finish it on the notes so you can look at it later. Or you to check, but the answer is 16/3. So if you get 16/3, you know you did it right.